So now let us take this next question. So in this question is same as the previous one. We have a simply supported beam with point load at its center. But here we have to find out YC. In the previous question we had calculated theta A, theta B, theta C and YD. Now I want to find out this YC. So C is a point located at a distance of L by 4 from center. Okay, so first step is we will draw the elastic curve, right? So this will be something like this, and this is the point C here. So we want to calculate this YC, and in the previous question we had calculated this YD. Okay, so I will not show it here. Okay, so these are my points A and B. Now let us recall the previous question. So as in the previous question, when we were determining YD, we had established a relation between YD and TAD because moment area method gives us the expression to solve this TAD but not YD directly. So we had established that from geometry it is and trigonometry it is very clear that this YD will be equal to this TAD, and this TAD can be calculated from moment area theorem. So here also in this question we have to determine this YC. So we have to establish some relation between YC and any other term which can be calculated from moment area theorem. Now it is not as simple as that of YD because YD was at the center, so it can be said directly that YD is equal to TAD, but we cannot say that YC is equal to TAD or TBD, right? So we have to establish the relation. So how we will do so? There are many ways to establish the relation. You just have to use common sense and some common concepts of geometry, trigonometry, etc. Right? So what I will do is, we know that we can solve such kind of values from our this moment area method, TAB, TBA, TAD, and something like this, right? So keep this in mind. So what I will do is, I will draw a tangent from B. This is my tangent at B. Now look closely. I want to determine this YC. Okay, so this is YC which I want to find out. Now what is this distance which I have marked? So observe here carefully. This is the distance of point C from the tangent B, right? So I can say that this is TCB. This distance is TCB. Okay. So let me mark some points here. Let me call this point C. Let me call this one as P and this one as Q. Okay. So now I will use basic geometry to calculate these or to establish a relation between these. Okay. Now we can say that, see these value points P, C and Q. So I can write the equation that PQ is equal to PC plus CQ, right? So out of these we want to find out PC. So I will write the equation for PC which is equal to YC. So PC will be PQ minus CQ. So if somehow, so PC is YC, as you can see PC is YC, so this is my equation PQ minus CQ. So if somehow I establish or determine these two values PQ and CQ, I will get YC also, right? So I will mark this as equation number 1. So first I will calculate PQ. Okay, so there are two ways to calculate PQ. I will calculate, so I will show you how. So see this triangle here. I will draw this triangle. This is my point P, this is B, and this line is PQ. right? What is this angle here? This angle is the slope at B, which is theta B, right? And in the previous question, if you remember, we had calculated theta B as PL square by 16 EI. You can see here theta B is equal to PL square by 16 EI, right? So I'm calling this equation 2. Okay, so this is my angle. Now in this angle, if you use trigonometry, then we can say okay, so first I am calculating PQ here. So we can say in this triangle BPQ, which is right angled at P, tangent theta B is what? Perpendicular upon base. So perpendicular is PQ and base is PB. Now what is this PB? PB is basically the distance between these 2 points C and B. So PB is L by 4. So I can write that tangent theta B is PQ upon L by 4, right? Now see this equation of theta B. Theta B will be very small angle because we know that EI will be a large value. So denominator will be quite large. So we will get theta B to be very small. So we can write down that tangent theta B can be taken as theta B for very small values of theta. Okay, this is a basic concept. So I can write this equation as theta B is equal to PQ upon L by 4, right? And theta B we have already calculated. So using equation number 2, I can write that PQ is equal to L by 4 into theta B, and theta B is PL square by 16 EI. So therefore PQ is PL cube by 64 EI. So in this equation number 1, we want to find out YC, so we have determined PQ. Now my next step is to find out this value of CQ, right? So how to calculate this CQ? See in this picture we have to calculate CQ. So what is CQ? As you can see, CQ is the distance, vertical distance of point C from the tangent at B, right? So CQ is equal to TCB, and we know from moment area method theorem 2 that this can be determined by calculating area of M diagram between C and B into centroid distance, centroid of this area, centroid distance from point C, because we are calculating TCB, right? So first we will have to draw the M by EI diagram. So this we have already done in the previous question, so I will just draw it quickly. So this is the M by EI diagram which we have obtained. So now see in this diagram, we have to calculate the area of M by EI diagram between C and B, and we have to calculate centroid distance from point C. So if this is the centroid here, so we have to calculate this distance XCG. So we can write TCB will be equal to area of triangle BCC dash multiplied by XCG. So what will be XCG? XCG will be in the triangle, this is 1/3 of the base. So it will be 1/3 of L by 4. XCG will be 1/3 of L by 4. So area of triangle will be half into L by 4 into PL by 8 EI into XCG will be 1/3 of L by 4. Okay, so after solving this, we will get TCB as PL cubed upon 768 EI. So this TCB is CQ, so I can write that CQ is PL cubed by 768 EI. Now let me call this, the previous one as equation 3 and this one as equation 4, right? So in equation 1 we had concluded that YC is PQ minus CQ. So YC is PQ minus CQ. So using 3 and 4th equation in 1, we will get YC is PQ was PL cubed by 64 EI and this was PL cubed by 768 EI. So we can take this term as common. So 1 minus 1 by 12 will be remaining in the bracket. So we will get 11 PL cubed by 768 EI. So this is the answer, that is the deflection at C, right? So this is how you calculate. So the basic concept here we have to utilize is, first we have to establish the equation relation between the value which we have to determine and the value which we can easily get from moment area theorem, right? And after that we can solve. So to conclude, in order to calculate YC, we must first calculate theta B. We must calculate TCB also, right? So this is how we proceed. Now I told you at the starting of this question that there are two methods of calculating this PQ. So first method I have explained. The second method I will also explain to you. So you can use any of these. So this was my elastic curve. This was point C, right? So this was my tangent. Sorry. This was point B, C, A. Now first we had drawn this tangent and we have to find YC. Okay, so this was Q, this was P, right? So CQ is TCB, right? And we had calculated that YC is PQ minus CQ. So CQ we can calculate by calculating TCB. Now we want to focus on PQ. So first method is by calculating theta B. Now how do we calculate in the alternate way? What I will do is I will extend this tangent beta like this. This has to be a straight inclined line. Okay. Now what is this distance from here to here? This vertical distance. So observe it carefully. This is basically giving, this distance is giving us the deviation or distance of point A from tangent at B. So I can write it as TAB, right? So this is TAB. Okay. Now I want to find out this PQ. So I will draw this triangle here. Okay. Before that this was my question, A, B, L by L by 2, and this point C was at a distance of L by 4. Now I will draw these triangles. This is my line AB and this is, let me call this point R. This is R. And this is my point P and this is Q. Now very simple, you can see in these similar triangles, which are those two triangles? Triangle BPQ, which is a smaller triangle, and BAR. So the ratio of the sides should be same. Okay, so this length is L by 4 and this complete AB length is L. So we can say that first BP upon BA must be equal to PQ upon AR. BP upon BA must be equal to PQ upon AR, right? So BP is, so I can write PQ upon AR is equal to BP is L by 4 and this is L, right? So I can write PQ equal to AR 1 by 4th of AR. And what is this AR? See here, this AR is TAB. So we can conclude that PQ is equal to 1/4 of TAB. Now we know from moment area method theorem 2 that TAB will be what? It will be the area of M by EI diagram between A and B into centroid distance from point B, sorry, from point A, right? So again we will look at the bending moment diagram. So this bending moment diagram between A and B is like this, and by EI diagram. This was PL by 4EI. This is L by 2, L by 2. So TAB will be area of this whole triangle multiplied by centroid distance from A. So I will divide these into two triangles, right? 1 and 2. And here we will have these two centroids G1 and G2. So half into, I will calculate first the area of this first triangle, half into L by 2 into PL by 4EI to its centroid from A. This will be 2 by 3rd of L by 2 because this whole distance is L by 2. So 2/3 of L by 2 plus the second area will be the same, half L by 2 into PL by 4EI into, now this will be the distance of G2 from A. So this much distance is L by 3, that is 1 by 3rd of L by 2. So from A, the total distance will become L by 2 because from A the total distance will be AD plus this distance DG2. So AD is L by 2 plus this distance is 1 by 3rd of L by 2. Right, so I will write it like this. L by 2 plus 1/3 of L by 2. Okay. Now we can solve this. So we will get PL square upon 16 EI as common for both of these terms, and in the bracket we will get L by 3 because these will get cancelled, plus this will be, I can write it as 1 plus 1 by 3 by taking L by 2 common. So it will be PL2 by 16 EI, L by 3 plus L by 2 into 4 by 3. So we will get L by 3 plus this will be 2L by 3. So L by 3 plus 2L by 3 will become L. So we will get PL square by, PL cube by 16 EI. So this will be our TAB, right? And we have established a relation between PQ and TAB as this. So PQ is 1/4 of TAB. So it will be 1/4 of PL cube by 16 EI. So we will get PQ as PL cube by 64 EI. And you can compare this with the PQ which we obtained in the previous alternate method. So here also we had got PQ as PL cube by 64 EI. So it's up to you which value you want to calculate. For so I will write it here at the heading, alternate way to calculate PQ. So for calculating this PQ, we had to calculate this TAB and TAB, right? And for calculating PQ in this previous case, we had to calculate this theta B. So it is up to you, and as per our convenience, we can get the answer.